It is time to start on the generator. You will not see it for a while, but I assure you it exists. I have my 200 amp ATS that I already installed. I have a little distribution box, and it all feeds this essential panel. I even have the 2-inch conduit already run for the back feed to the main panel. But I have decided, after staring at this for a while, that I'm going to redo all of this because I can't leave things alone. And by all of it, I mean the ATS, not the whole service. Don't worry. Let's get these covers off so we can be unsafe. Ah, that's better. Here is our essential panel already wired to our ATS. That's a 200 amp ATS Kohler. And our little distribution box, like I said, for the back feed to the main panel. Pipe is already run. I did not run the wires for that except for the ground. So the original concept was I had this 175 amp circuit breaker feeding the ATS, and then that would automatically transfer the power for that essential panel. And then if I had a long-term outage, I could transfer the whole house using a back-fed breaker, just like an interlock kit in a regular house. That is still the plan. I just want to make a custom transfer switch. So the first thing I really need to do is remove the old one. And right now everything is still powered up. So I'm going to take this spot that was for the generator backfeed breaker, and I'm going to add a circuit breaker. And I'm going to use that as a temporary circuit breaker to feed that essential panel while I work on everything. So we're going to run a few wires up through the trough, and we're going to backfeed a 100 amp breaker or whatever I find in that slot there. That way I can remove those wires on the bottom, and I won't have to get everything done in a time crunch. Once I remove those wires, I can just repower the panel and we're good to go. Here is the I-line breaker I am using. It is an A and C phase breaker. That's why the middle is missing, those middle fingers. I also needed a regular panel mount version of that 150 amp breaker, and the easiest way I could find to get one is to tear it out of one of these enclosures. You can get these enclosures pretty cheap, and sometimes it's actually easier to get this than it is the breaker itself. So that's what I did. I bought one just to steal the breaker out of it. So there's your pro tip for the day. That being said, I would never recommend that anyone violate the UL listing on an enclosure like this and steal parts out of it. That is absolutely a no-no. You should never modify any piece of electrical equipment, and you would never see me doing such a thing. Anyway, there's the breaker, and here is the I-line next to it. And the funny thing is, these breakers are pretty much identical in rating, but that I-line breaker is about 4 times the price just because it has that kit on it to go onto an I-line bus bar. So yeah, that kind of sucks. That being said, normal people don't have to worry about buying I-line breakers for their house because they don't put I-line panels in their house. Here I am installing that circuit breaker. I want to go ahead and turn it off first. If you've never put an I-line breaker in before, it's pretty simple. They got these tabs on the back plate that you use to pry the breaker in with a screwdriver. And yes, that is actually how you're supposed to do it. And you put that little screw in, make sure it's all the way on the bus bar, it's lining up with the other circuit breakers, and make sure the screw lines up, and you're good to go. And those other tabs further out are if you have a much larger breaker. Now we just need a circuit breaker for the QO panel, and we'll dig through our pile of junk. There's a 100 with some messed up lugs, but I think we can make it work. And this is probably a good time to justify having an I-line panel, because I've never liked putting large amperage breakers or large current breakers in the QO panels. I know you can go up to like 125 or even more, depending on the style of breaker, but you're relying a lot on those tabs for a good amount of current. So that's one of the reasons I put that big panel in, is because for all the larger circuits, I'd rather have something commercial grade. So we're going to be running 2 hots onto our A and C phase of the circuit breaker. We're going to run a neutral to our neutral bar and a ground to our ground bar. Pretty straightforward.
Easy peasy lemon squeezy.
We can run through our messy trough. Please don't look at that. I still got to fix that. Down one of these 1-inch pipes and backfeed into our 100 amp breaker. And then obviously our neutral will go to our neutral bar down there, and our ground to our ground bar. The grounds and neutrals are separated in this because it is a sub panel. That gives us plenty of room to get rid of all these larger wires, the piping, everything that needs to be removed. Now, one thing I did want to do, which isn't completely necessary, is I want to phase it the same in the I-line panel and at this panel. So the way you want to do that, or the way you want to figure out which phase is which, is turn your circuit breaker on first. I got 240. And if I take one lead and go down to the bottom, because that's what I'm comparing it to, you can see I have 0 volts on red. That means that phase is the red phase. If I go down to the other one, I have 240, which means it's the opposite, and that is the black phase. Go to black, I have 0. So if you have 0 volts going from one phase to another, you're on the same phase. And if you have Voltage, you're on an opposite phase. In this case, there's only one other. In three-phase, you don't know exactly which one you're going to, but you know it's not the same phase. Of course, that was kind of a stupid test because everything in that panel is actually already phased correctly. In the I-line panel, it's even easier because they actually just use letters, and we're using all A and C phase in this panel because in an I-line panel running on single phase, you only use the top and bottom bus bars. At this point, I decided I'm doing a lot of work on the service of this house, and I don't really have a diagram. Now, I don't need a diagram, but you never know. It could be helpful in the future if I go senile or something. I am making a single line diagram or a one line diagram. I'm not real familiar with these. Like, I've read them, but I certainly have never created one. So, if you're an engineer, please go easy on me or at least tell me how I can improve. I'm using TinyCAD. This is a free CAD software. I've gone through a bunch of different free softwares trying to figure out one that's good for making electrical diagrams. And in terms of the free ones, I actually like this one. It's pretty simple. They are a little lacking on the symbols, but I know you can add your own symbols. They definitely didn't have exactly what I wanted for all the symbols. But they didn't bug me about a subscription or an email. There's no ads. I don't know. Overall, I'm pretty happy with it. So I've been playing with it a lot lately, and I use it a lot on this project. They're not sponsoring me or anything. I just searched it, and this is what I came up with. If you have a better free software you use, let me know in the comments. I'll try it out. And I will modify this over time and try to make it better, especially when you guys shame me about how crappy it is. But overall, pretty happy with how it turned out. At least it gets the point across. And I know if you're actually reading this diagram, you're looking at that generator backfeed and you think he's going to kill himself. I have a plan for that. Just wait. Just be patient. Alright, it's time to get back to the real work. I just bought black wire and some phasing tape because this is not permanent, so I'm not going to buy actual color-coded wire. The wire is actually too small for the breaker it's hooking to in the I-line panel, but I don't really care because I wasn't going to buy a $700 I-line breaker just for this temporary installation. It's going to a 100 amp breaker. It is rated for 100 amps, but on the other side, it is going to a 150 amp breaker. Now, in theory, if that wire were to completely, catch fire or turn red hot, it's all enclosed in the trough and the piping, so I'm really not worried about that. And the fault would have to occur between the two panels, because if the QO panel starts drawing too much, it is protected by a 100 amp breaker on 100 amp wire. It's just that 150 in the I line that wouldn't trip theoretically. So yeah, that's all my whining and excuses out of the way, but I know someone is going to see the AWG markings on that wire and tell me I'm an idiot. Which I am. But, this is America. I'm allowed to be an idiot. Speaking of which, I did not turn the power off until I absolutely had to, and that's why I was checking to see if any current was flowing on that ground before I disconnected it. I mean, it just would have been a little, sparky spark, but decided to do that anyway. Here I am stripping the neutral, which I am also landing hot.
Feeling hot, hot, hot.
Because it's fine. I'm just creating a couple more paths for the current to flow. But luckily, there isn't a huge unbalanced load, and most of it's going through that 3/0 below. I am stripping the wire with a razor knife. I know I am a savage from the dark ages, but, it's fine. It's temporary. And also, as long as you don't cut too deep, you're not going to hurt the copper. I did also double check to make sure that 100 amp breaker was actually off because, it would have sucked if the other end was touching the ground. Would have had a even bigger sparky spark to worry about. But that's the QO panel all hooked up and ready to be turned on. Now we move on to the I-line panel, and it's pretty much the same thing. We're just playing with bigger lugs. Ground in the ground bar, as it should be. I even wrote down the torque spec back in the day when I wired this thing originally. I need to make that a sticker instead of Sharpie, but we're always improving. Neutral onto the neutral bar. All very simple. If you're following along at home, make sure you turn everything off while you're doing this. All it takes is one slip and to let that neutral fly away from you. And you got some pretty serious fireworks, so wear your gloves, wear your arc flash suit, or turn it off. Don't do any of the things I'm doing. But I am at my house, not at work, so there's a whole different set of safety rules here. Maybe I'll show them to you one day. They're really interesting. Moving on to our circuit breaker, we're going to be landing red on C and black on A, because we went to all that trouble to make sure things were phased correctly. I'm sure someone will say, oh, it's not a phase. It's a split phase service. I don't know. Is it still called a phase when it's split phase 240? I call it a phase. I guess you can call it a leg, whatever. Whatever makes you happy. Got that tightened down. Nice and tight. You can hear the clicks on that fancy torque wrench. Or maybe that's just the stress fractures I'm creating in that aluminum lug. It's fine. There's right, tight, and there's broke. Don't be a wuss. Go all the way to broke. Here I am just double checking, make sure everything is hooked up correctly. That is assuming I phase the wire the same on both ends. That would be a big issue. But everything went pretty easily. Luckily, I ran that 2-inch pipe up to the trough when I originally did this just as a spare. It was a little tight in that 1-inch pipe. It may even be over the actual fill of the pipe, but it fit. It's temporary. It's actually technically a nipple because it's less than 2 feet. So it's fine. It's good. Time to turn this thing off and get crazy. Here I am turning the power off to the original ATS, and I'll actually make sure it's off since I'm about to put hands on it. Looks like we're good. And now we can go into full demo mode and, try not to break anything. I actually really dislike the lugs on these QO subpanels. They're so flimsy. I mean, they just turn every time you try to tighten the lug, even if you're using a torque wrench. Not a fan of that. I wish they would have braced them a little better. But now that our wires are unhooked from the panel, we can turn that breaker on, which nothing happens because the one in our main panel is still off. Or not our main panel, but our large panel. Turn that on and look, we have light again. And if we did it right, we don't have anything backfeeding to hurt us. So now we just got to tear everything apart properly. If you're curious about how much current we're drawing, at this moment, about 20 amps. 20 and 10, I know it's very unbalanced, but it's pretty good lighting load in that basement. But all in all, I'm never going to draw 100 amps. It's more than enough for what we're doing, especially temporarily. So at this point, you probably have a whole lot of questions, and one of those questions is probably, why didn't you just put a 400 amp switch in and back up your entire service? And there's a few reasons for that. None of them are very good, but the main reason is, and I know you hate to hear it, is cost. I mean, a 400 amp switch is, $2,000, $3,000, $4,000, where a 200 amp switch is only like 700 or, somewhere around there. It's really not that much. And at the time, that did matter. Another reason is I didn't want my entire service, utility side and generator going through one device. Because if you have a contact burn up or it gets stuck in the middle, a lug burn up, whatever, you lose everything. You have nothing at that point because your generator and your utility cannot feed the load. Now, is that going to happen? Probably not, but it is on my list of excuses. I also never thought I'd have a generator large enough to really do the entire house, but I did end up finding a good deal on that Cummins, so I am grateful for that. So yeah, that's my reasoning for only backing up the one panel as I originally planned and having a physical breaker backfeed for doing the entire house. So now that I got all that demoed and I got this big empty space on the wall, it's time to think about what we're going to do next. And I decided to finally do it somewhat properly and create a proper diagram first. I jumped back on TinyCAD and started drawing. This is a rough draft, so things will change. But at least I'm starting with a legit drawing this time instead of just some scribbles on a whiteboard. Makes it a lot easier to figure out all the devices you're going to need to get and where everything's going to go and how it's all going to relate. But basically, I'm just creating a caveman version of a transfer switch. I'm taking a perfectly good ATS and I am making it much more complicated. I'm going to use actual voltage monitor relays that can be easily replaced. All of that's going to go back to my PLC panel. The PLC is going to be the brain of this operation, controlling all the timers and the transfer, the auto exercise, all that good stuff. That's already in that circuit board. I'm going to make it all go through the PLC. I'm also going to have some manual modes, but I don't know. You'll see as I go. There's a lot going on, but I have big plans, big plans.
It's great.
It's going to be great.
That's going to be great.
It's going to be great.
That's going to be great.
From this point on, I'm going to try to be a little more proper about my documentation, create real prints and real bills of material. And if you guys ever want to know something that I'm using, I'm going to try to make it accessible to you. I don't recommend you do what I'm doing, but if you say, hey, I want to use that terminal block, or hey, I want to use that, whatever, I do want to make it so you guys can access the bill of material, the prints, whatever you guys want to see. So I'll work on that. But for now, we're going to tear this transfer switch out because we are actually going to use the switch itself. We're just not going to use the enclosure, which is good because I bought this thing brand new and I never even used it. So at least all of it won't go to waste. Let's get this pesky wiring harness off because we can do much better than this. I mean, my God, it's all white unlabeled wires. It's a freaking nightmare. That being said, if any of you need a 200 amp Kohler ATS wiring harness, let me know. I'll send it to you because I definitely don't need it. There's our switch, nice and beautiful, and I almost said naked. That was kind of weird, but it is kind of naked. I'm also going to use this ground bar. because it has actually the perfect amount of large lugs for all the power wiring, and then plenty of small ones to hook the control wiring up. So we're going to reuse that as well. I am not going to use the neutral bar because I have a different plan for that. So if you need a neutral bar, a wiring harness, or this circuit board, let me know. I'll try to get it to you because I'm just going to throw it away. So the next step will be getting an enclosure for this monstrosity, and I got very lucky because EXM reached out to me and said, hey, you should try out our BoxCAD tool, design up a cabinet, and we'll send it to you. So that's cool. I know you guys have seen me in my past videos drilling holes, punching them out, notching them, measuring them all out, all that good stuff, but you really don't have to do that anymore. I mean, they can just cut it out with a CNC laser or whatever the hell they use, and everything's perfect. So as long as your measurements are in the right place, you can have it all pre-done. That being said, you do have to have actual measurements to go off of. You can't just go full cowboy like I normally do and start laying push buttons out on the front of it until it looks good. So I did have to make a little bit better of a plan this time to make sure I got everything right, but I had all the push buttons cut out, as well as a few other holes, and you'll see what they're for later. I also opted for the 3-point latch and the wall mount kit, so there's definitely a lot of customability. It's extremely customizable. And just like that, we have a package, and no truck will ever drive down my driveway, so I had to break out the old Ford. That's right, Dodge and Chevy guys, I bet you can't do that. And by that, I of course mean fail at getting the pallet out of the bucket, because I don't have a set of forks for this thing. Thankfully, I quickly realized that this pallet wasn't nearly as heavy as I thought it was going to be, and I just quit being a wuss and got it off of there. I was pretty excited for this package. It's not every day you get a brand new industrial enclosure at your house. And as I unwrapped it, I thought, damn, did they really put the backplate on the outside? No cardboard, no nothing? But it turns out they actually sent me an extra backplate, which I'll go over later. The regular backplate is already inside the box, which is another thing they do, which I think is kind of cool. It's not in a separate cardboard box. It's already installed. They do come standard with a galvanized backplate, and I'm actually a fan of those because you don't have to always scrape the paint off when you do your grounding, and they're extremely corrosion resistant, so that's pretty cool. Now I just need to lug it into the basement without falling down the stairs and killing myself, and we'll be home free. Alright, we made it. The Eagle has landed, and I didn't even drop it, so that's pretty cool. Get this thing opened on up and see what they sent us. Wow, plastic. Very nice. Damn, they even put my logo on it. This is getting way too fancy for this project. This is actually not my first time ordering from EXM. I've used them at work before, but this is my first time using them and actually taking advantage of all the pre-cut holes and everything, so this was definitely some new territory for me. I felt very spoiled, that's for sure. Open her on up, see what we got. There's all our holes. I even had studs pre-welded for the straps for all my wires going to the door, just like I did on the PLC cabinet, except now I don't have to drill and tap. I have studs already ready to go. They'll do as many as you want. There's that galvanized backplate. They did give me a paper holder, which I may or may not use. It's got the sticky too, which is nice. You can stick it while you drill it. There is the wall mount kit. Have to put that on. Grounding kit. Pretty sure that comes standard. They also sent me a little cooling fan, which I actually don't need. And this is the handle for the 3-point latch, which I do need to install. They don't put that on to begin with because it'll probably punch through the box during shipping. So I think that's a pretty good idea. The 3-point latch seems pretty legit. They got that little roller on the side so it doesn't scuff up the paint on the side of the cabinet when it latches. And then on the top and the bottom, they have more of a wedge system instead of wheels, so you don't have that rattling every time you open and close the door. They do include a little quarter-turn latch on the front of the door while it is being shipped, but that is not a permanent latch, so you just pop that thing off, pop your new handle on, and you're good to go. I almost feel like I need to keep this for something, but I don't know what. I'll throw it away. Now, as I mentioned before, I did have 2 other holes cut in this door, and the top one is for this circuit breaker, which, thank the Lord, I measured out well. That's a nice fit. And the other one is for the manual transfer handle of this transfer switch. So that looks pretty good too. Not perfect, but it was never going to stick through the door because it's not the highest point on the transfer switch. Either way, we're being fancy. Both of those things will be accessible with the door closed. Here's that extra backplate they sent me. They just wanted to show me their capabilities for what they can have pre-prepared. They can have tapped holes, they can have riv nuts, they'll even put the DIN rails on for you. Now, I didn't need any of that because I didn't know exactly where I was going to put everything, which I usually don't. So I just opted for a blank backplate, but I am grateful for this extra one because I'm going to start cutting it up and using it for metal. Probably not what they had in mind, but, you know, it's fine. It's mine now. I'm not giving it back. So the reason I am marking out this backplate and cutting holes out of it is because I need a couple sheets of metal to stand my transfer switch and my breaker off of the backplate, because I want them to line up with the door. I need them to stand off the backplate 3 or 4 inches. Now, normally in a proper panel building shop, they probably have nice metal plates bent and create like little shelves for these things to sit on. But I don't have a proper metal brake and I'm a bit of a hack, so I'm not going to do that. I'm going to cut these plates about the size of the devices. The devices will screw onto those plates with threaded holes, and then I will stand them off with 3/8 all thread, and I'll sleeve that 3/8 all thread in 1/2-inch pieces of rigid pipe. So it'll definitely be solid. It might not look as good as it could, but it'll be good enough. That being said, I was extra grateful to have some galvanized plate to cut up, because at least it'll match the backplate and be less obvious. It'll almost look like I planned it out that way, but I assure you I did not. I am using the trusty angle grinder to cut all this out, because as far as I'm concerned, it's the only acceptable tool to cut anything, because it will cut anything. And if you're one of those people who's afraid of an angle grinder, you're actually pretty justified. I mean, have you ever seen those safety videos, those pictures where the cutting wheel actually flies through safety glasses? Yeah, they're pretty terrifying, but as long as you don't watch those videos, you'll be safe. I think that's how it works.
Yeah, that seems about right.
I guess you could use like a jigsaw with a metal blade, or a sawzall if you're an absolute caveman, or a plumber, but I'm not doing that. Now that I got my plates cut, I went ahead and filed the edges down so I don't slice my hands open, and I'm marking all the holes for my transfer switch, or at least all the mounting points. They were only using, I think, 3 or 4 bolts to hold it on originally, but I'm using every single available mounting point, because why not? I just want to make it as difficult as possible for whoever has to replace this, which of course will be me. Moving on to our circuit breaker, thankfully I did not lose the screws that hold this thing on, because if anyone has replaced circuit breakers before, they know that those screws always go missing. But I'm the one who took it out of that box, so it would only be me I could blame. And also, thankfully, they are 832s. I'm kind of surprised they weren't some strange thread or some metric fine pitch or whatever, but they're just regular 832s, so I already had a tap for it. Here's another pro tip. If you don't have one of these mechanical carpenter's pencils with the super thick lead on them, they are great for marking deep holes. I mean, I used to try to use like drill bits and stuff to mark these, and it was a nightmare. That thing was perfect. It just went right down there. I think they have markers that do that too, but trying to line up an 832 that's 4 inches long through, 4 inches of circuit breaker can be a real pain in the ass. Speaking of that circuit breaker, I didn't even say what it was for. That will be the circuit breaker for the generator, for the incoming power from the generator. So if I need to shut it off, I can do so without going all the way outside and turning the generator off. It's just a local disconnect and a local overcurrent protection for that power source. I probably actually could go bigger with the entire generator circuit. The generator itself does say 175 amps at single phase, but I just did 150 to be safe. I mean, I'm never going to draw that much. Worst case scenario, I guess I could run a larger circuit out there, but because I'm changing the generator from 3-phase to single phase, I did get a little confused on what size the circuit breaker should actually be. And will be replacing the circuit breaker in the generator as well. So I essentially had to buy 3 circuit breakers for this generator. One in the generator, one when it comes into the house, and then the backfeed to the main panel, or the large panel, which is also 150 amps. So should be more than enough. Here I'm just drilling, tapping, deburring all the holes. I'm also using what's left of that backplate as a workbench, so that's, I'm making the most out of this thing, trust me. Drilling and tapping holes in metal is one of my least favorite things to do in this world. I don't know what it is. It's just so tedious and annoying. But we got through it. There's all our holes drilled, deburred, good to go. Plates are ready. So now we can see how we did, see if everything actually fits. And if it doesn't, I'm going to cry, because I either have to re-drill all these holes or completely remake the plates. But thankfully, there was no tears, because everything seemed to work out pretty good. There's the circuit breaker mounted and ready to go. And we'll just do the same thing with the old transfer switch, which has, like I said, about 1,000 screws. I am using stainless steel 832s with large heads. Those are my favorite. But there's definitely more than enough to keep this thing still while I tighten down the lugs. I actually chose this transfer switch because of its simplicity. I mean, there's really not a lot going on here. You got your 2 sets of coils for your normal and emergency transfer. You got all your power and then a few auxiliary contacts for the position of the switch. But Really nothing too crazy. I do believe it is a 240 volt coil as well, which makes sense because that's what you're feeding into it. But we'll tie into all of that when we do the controls. For now, let's get these things elevated and try to get them to line up with their associated cutouts. Normally when I build panels, I'm not really worried about what's on the backplate because I just kind of figure it all out as I go. But in this case, because the things on the backplate had to line up with the door, and I didn't want them to be in weird spots on the door, I really had to do some thinking about where everything was going to go on the backplate in relation to the door. It didn't really matter with the push buttons and lights, but with these two devices, they're not going to look quite lined up in the panel, but that's because the holes on the door do line up and are straight. So it was definitely a little bit of a change of mindset because normally I don't have to worry about that. I don't do a whole lot of panels where things are sticking out the front, and I hate those rod mount disconnects, so I don't even really have to do them usually. The blue single gang nail-ons were absolutely essential for this process. Every industrial control panel builder keeps, the nail-on box for spacing their components out. Pretty sure that's what they were invented for. All right, we got our spacing right, so now we can get our measurements for how far these things are going to sit off of the back plate, and we can start cutting our rigid spacers. Now, the rigid spacers weren't 100% necessary. I could have just used all thread and spaced that out with the nuts on the all thread, but I figured if I actually clamp down on these spacers, it'll make things a lot more rigid and keep everything from getting all flimsy. Now, if you've watched any of my previous videos, which hopefully you have, you're probably wondering why I'm going to all this length to make things safer and to make it so you don't have to open the door and operate these devices. And I kind of asked myself the same question, but I'm trying to go the extra mile here because I have thought about what if someone else has to operate this system? Obviously they're going to need about 1,000-page instruction manual, but at least if I'm not here, no one has to open up any panels to do anything sketchy. And even with the generator backfeed, I was just going to have, a breaker, and hey, don't turn that breaker on while the main is on. But I am going to go the extra mile with that too, so that no one blows themselves up when I am not there, because, that would be unfortunate. Here I'm getting all my all thread cut to length using the old bandsaw, which is definitely one of the best options for all thread. I know I said you should cut everything with an angle grinder, but the bandsaw is definitely second best. I mean, this thing's awesome. You almost don't even have to deburr the ends. You can get nuts on them without doing anything. I mean, back in the day, you had to run a nut on first or you were screwed, but they make such clean cuts now, it really doesn't matter that much. That being said, I did deburr everything. Don't come at me in the comments. I did deburr everything. I promise. Moving on to step 100,000 of this process, we're going to go ahead and put our all thread on our plates temporarily, because we need to figure out where the holes are going to be on our back plate. So we're going to go ahead and get all of these studs mounted to our plates, spaced out according to our measurements, and then we'll plop them onto the back plate and see where we want everything to line up. If you're wondering why I have so many nuts and washers laying around, it's because I have them left over from when I built the pipe racks for the original conduits going through my house. So I have a ton of hardware ready to go. There's the breaker and transfer switch all spaced out and ready to go. Plop them down on that back plate and then just start fidgeting things around until everything actually lines up, which can be pretty tedious, but it really wasn't too bad, especially since I had the measurements almost all the way ready. But even once it is all lined up, I have to make sure that they're somewhat straight for when I mark them on the back plate, because if your all thread is off, and you mark it, and then you go to put it in, and it's sitting straight, and the mark was off. It's just a whole thing. So, it's tedious, but it's worth it. I also made sure I cut my all thread about 1 inch long, because this isn't the final depth of the all thread. It's going to have to go into the back plate and have a nut and a washer and a lock washer. So that's why the all thread's sticking up so far at the moment, because it will sink down into those holes. You could also try to do this strictly by measuring, but you would have to have everything perfectly spot on. And generally, I would recommend that you just, don't suck at measuring, but the further you have these devices off of the back plate, the more variation you're going to have. So in this instance, I decided I would just straight up put it on there and mark it where it looks good, because I think I'm going to have better results. Now that we have our super accurate marks, we'll go ahead, center punch, do our pilot hole, and then drill our final holes. I opted for a unibit in this situation for the same reason most people opt for a unibit, and that is I did not have a sharp 3/8 drill bit, and I didn't feel like sharpening a drill bit. So, it's fine. I mean, this backplate is pretty thick for being a backplate, but overall, unibit was fine. It's also nice that you can deburr the holes at the same time using this drill bit, at least on one side. Still had to flip it over and do the other side, but I assure you, I did. Holes are all done, plates are all done, everything's measured out, time to prep the final product. I did deburr everything inside and out with these pipes and all threads, plates, all of it. You shouldn't be able to get a cut on any of it unless you try hard. And the final cherry on top will be, I'm going to spray galv the edges where I actually cut the galvanization off. Not that it matters even a tiny bit. This is going to be indoors in a conditioned space inside a cabinet. But, you know, if you're going to do it, try to do it all the way. Unless you're lazy or you forgot. In that case, if someone calls you out, you should argue till your last breath that what you did is the right thing to do, even if you know it's wrong. That's the tradesman's way. I know you can't see it, but I did do nuts, split washers, and flat washers on the back side. And I didn't do any washers on the front side because those pieces of rigid pipe need to be able to slide over those nuts. And you can't really fit the rigid pipe over any kind of washer. So I just had to do it that way. Also, I know I'm the worst. I'm using channel locks directly on the threads, but we're not going to use that part of the threads. They're going to be completely covered up by the pipes. So get over it. You'll be fine.
Oh, come on. Stop whining.
Got all our spacers slapped down on there. Now we can put our plates on and see if they actually line up without me manhandling anything. And so far, worked out pretty good. Everything lined up all right. It honestly blew my mind how long all this took. I probably could have built an entire other control panel in the time it took me to just mount these two components. But I shouldn't be surprised. I've done this kind of thing before. It's just been a while. But I don't really miss it. So hopefully after this, that'll, be the last time for at least a few months till I have some other harebrained idea about replacing something that shouldn't be replaced. Got my two little platforms built. Now it's time to do the final mounting on my two components. Circuit breaker screws still line up, so that's good. Make sure you don't put it on upside down. And there is our transfer switch. When I'm actually going to use all the screws, tighten them all down, it'll definitely be sturdy enough, that's for sure. One slight advantage of using these standoffs instead of like a custom bent plate is I can actually run wires behind them. So that's kind of nice. When I do the power wiring, I might actually take advantage of that and make the panel a little cleaner. Now that we're back in the enclosure, we're just going to do some of the final fit up. And obviously this backplate is going to come back out again when I do all the control wiring, but I just want to make sure these two components are exactly where they need to be. One thing I had to learn the hard way is you can't just line everything up with the cabinet on its back. You need to stand it up and have it in the actual configuration it will be, which is upright on a wall, because gravity is going to pull some things down, at least a tiny bit. I mean, the door itself is going to sag at least a tiny bit with gravity, so you got to consider that. You got to stand it up and make sure it still works with the cabinet in its final orientation. Speaking of which, this is the final orientation of these two components. I know this whole video has seemed like I did hardly anything. They did end up super solid, which makes me happy. They should withstand torquing all the lugs down. And that's pretty much it. I got them actually very well lined up. Look at that fit. Oh my goodness, what a professional. Let's get a closer look. Oh yeah, that's just too good. There's the hole for our manual transfer. Happy with that too. And that's it for this video. It was pretty tedious, so it took a while. Like I said before, I do have a plan for the generator backfeed, so that will be in another video. Most of you probably know what I'm holding in my hand, but we'll get them installed one way or another, and we'll do all our components, all our control wiring, mount the cabinet, pipe it all in. I'll try to be more descriptive of how everything's going to work. But yeah, still a ton left to do. It's going to be a lot of videos. Big thanks to EXM for providing the cabinet. If you guys are interested, I'll leave a link in the description, and I'll see you in the next one.